Assalamu alaikum wa rahmatullahi wa barakatuh. In this lecture, we will discuss about duct. Okay, types of duct and how to size as per recommended velocity and friction as per the SMACNA and TW144 standard as per the standard. Okay. So without wasting time, let's start. And before that, as usual, I request you, if you have not watched my previous lecture, so go and watch first. Okay, so see, in previous lecture I already explained about the how to place air terminal. Okay, and as we know that for this space we need 217 liter per second. Okay, 217. So this is the supply air terminal and this is the return. So I already here mention 108.5. okay, and here 108, okay, 0.5. so total 217 liter per second, okay, per second. And as return also I distribute each 108.5 liter per second. Okay, so now come to the topic. See, before that we must should knowledge about the duct. Okay, so see here the duct types. How many duct types? Supply duct, return duct, fresh duct and exhaust duct, right? There is 4 category of duct. So if we will select here or here the duct, see, then here system type will come, system classification supply air, and system type will come supply air. Okay, so how many ducts here? Supply air, return air, exhaust air. There is no any fresh air duct. So we know how to create. Okay, so there is 4 types of duct. Here also if we want to create, we can create here duct system, right? See here, and we will make the duplicate and write the fresh air duct. Okay, I will explain all these things when I start Revit tutorial with designing standards. Okay, and I will upload many more videos about the Navisworks Revit. So if you want to increase or boost your skill, so be on my channel, and also I request you subscribe. Okay, so see how many duct types? 4 types. Okay, and after that duct shape is also important, like rectangular ducts, round duct and oval duct. Okay, most commonly use the rectangular and round. Okay, air duct, and here round rectangular duct. See the rectangular duct here written, round duct and oval duct. Okay, so already it is given in Revit 4 category of duct, 3 category of duct types. Okay, and also the material is important as perspective of the use. Okay, the most commonly used is galvanized, right? This galvanized iron most commonly used, and we can use this duct supply, return and fresh. All 3 types of air we can use the galvanized. Okay, and also it is strong The second most is SS. Okay, we use in mostly laboratories and hospitals. Okay, so two places important for this SS. Okay, use, and also it is costly compared to the GI duct. The third one is aluminum, most commonly used in where clean rooms. Okay, the aluminum duct, this type of duct, aluminum material, we use in clean room mostly. Okay, and the fourth one is mild steel. This duct we use in kitchen exhaust, industrial exhaust, most commonly all type of exhaust we can use this mild steel duct. Okay, less cost compared to the SS, stainless steel, and GI, and for corrosion resistance we have to paint this with red oxide. Okay, so mild steel oftenly used in industrial exhaust. Okay, the fifth is pre-insulated ducts. Okay, this duct is already insulated with the, we know, with the lining and the insulation of fiberglass. Okay, so already everything is installed, pre-insulated. Okay, and just we have to install at the site, most commonly used in office, mall. Okay, the sixth one is fabric. We often seen this type of duct in swimming pool and sometimes small supermarkets, this type of fabricate ducts, right? And the seventh one is flexible duct. We know to connect the air terminal we use this flexible duct. And the eighth one is fiberglass duct, this type of duct. Okay, so we know how many types of duct. There is 8 category of ducts, 8 types of duct materials. Okay, the first one is GI, SS, aluminum. This is commonly used, and for exhaust we use the mild steel. Okay, and for offices we use the pre-insulated duct, right? And to connect the air terminal we use the flexible duct. So this type of duct material we must have knowledge, okay, while going to a site. And see, the duct insulation, it is very important. After sizing the duct, we insulate the duct 25 mm with fiberglass. Okay, this is the insulation material, fiberglass, 25 mm. When it is inside the building, the duct is inside the building, then we use 25 mm fiberglass to insulate the material. But when it is outside, we give 50 mm. Okay, this you should remember while going to interview. So this is very important. If interviewer asks, then tell me how many mm we give the insulation. So you should explain that 25 mm when inside the building, when duct is inside the building. Okay, when duct is outside the building, then we give the insulation with 50 mm fiberglass with aluminum cladding. Okay, aluminum cladding also we give when duct is outside the building. And we know that when machine runs, then some vibration, noise could come. Okay, could come through the duct. Okay, so for that avoid the noise, we give the lining. Okay, from the machine to 1.2 meters we give the lining. That lining is called acoustic armaflex lining. Okay, to avoid the noise inside the duct. This this insulation is outside the duct we give, okay, outside the duct, here outside the duct, but this lining we give from the machine to 1.2 meter. This is generally we use 1.2 meter inside the duct, okay. The black color we often we all know the black color one, acoustic armor flex, the name is acoustic armor flex. This is also a insulation material, okay. So this lining we give inside the duct, okay. And after that, if the insulation is clear, then the next point is duct assembly, right? And the next is duct assembly. So there is two method to connect the duct, okay, to assemble the duct. The first one is slip and drive. This is drive and this is slip. So through this assembly we connect the duct, okay. And the second method is flanges. With the help of flange, okay, the duct assembly. So there is two method, one is slip and drive and the second one is with the help of flange. This is flange and we connect with the help of nut and bolt, okay. The eighth one is recommended velocity. So we will see. Suppose this is the FCO, right? This is a FCO, and how many liter? 200. The main duct is 217 liters. So I have to size the duct, right? This is one software, duct sizer. We can also size with this with the help of this software. Also we can size the duct with the help of Revit, but it is must client don't recommend. This is the reason. This is very famous software, this duct sizer we use, okay. See here, the first one, here we can change the unit, okay, either metric or the US unit. If metric I select, the first one we use standard. This is the standard. The second one, when we size the supply air, and this one is when we size the return air duct, okay. And after that, this is the of course fresh air and exhaust air, but anyone we can select. The duct's size will not affect, okay. So most commonly we use the 50% relative humidity, okay. The main duct is 217 liters, right? And what about the head loss? If we use the equal friction method, it means all the duct throughout the system head loss should be equal, right? Then it is the equal friction method, right? So see, the most commonly as per the standard we use 0.05 to 0.1, okay. You have seen a lot of videos on YouTube, then they use 0.05 or 0.1, or the mean of these two value is 0.08, right? But here it is given, see, if the system are small or designer does not have access to a computer program, okay. If the designer don't have the computer program, Okay, then we can use the value 0.05 to 0.1. okay, but I have the computer and the system program, right? So we have to fix the head loss, okay, throughout the system, and then we can size the duct, right? How? See, this is carrier this is carrier recommended velocity for low velocity system. Okay, this is, so if I'm going to size the duct for office, here see, here see the office, right? This is the one. This, if I will consider the noise generation factor, then I have to fix this value. Okay, or if for duct friction method I am controlling, then for supply I have to take 2000, and for branch I have to take 1600. okay, so for comfort region we must control the noise, then we have to follow 1200 velocity, right? But this is it is quite high. Okay, we can take this value 1200, no issue, but it is quite high. Most commonly, see, most recommended velocity as per the practical experience is this. For conceal and FCU unit we have to take 700 to 900, okay, not 1200. This is practical experience. This is not any reference or standard, but for practical experience we have to take 700 to 900. okay, convert in metric, this is the one. Okay, for AHU we have to take 1400, and for fresh fan we have to take 1500, and for exhaust 1700 fpm, right? So forget all this thing and follow this one. If I'm not recommending, but you must follow this one, okay, as because this is the most commonly used and practical, right? For FCU the velocity is 700 to 900. So in this system, see, in this system I am using FCU, so which velocity I have to follow? Of course this one, 700 to 900, right? This one. So I am taking 3.5 or 4.5, so mean value is 4, right? 4. See, 3.5 plus 4.5, 8, and divide 2, mean value will be 4, so I am taking 4. It is good. So here I am taking 4, but here I am not taking because I don't know the head loss. Okay, I know the velocity 4. So see, what is now the head loss is 0.80, and here 4. So now the head loss is 0.825. I am taking 0.82. So this head loss will be equal throughout the system. Okay, and now I can start to size our ducts. Okay, remember 0.82 is the head loss value now. Okay, so see, here the main duct is 270 liter, and the 4, so 262, okay, mm is coming. So here if I will take 250, then it will come 225. if I am taking 300, so here it will come 200. okay, as we know the aspect ratio here, if aspect ratio, right, the aspect ratio as per the standard aspect ratio of the duct as per the standard is 1:4, right? Or the longer side divide shorter size, right? Shorter size, right? So here the duct is coming, see, the duct is coming 300 by 200, right? 300 by 200. What is aspect ratio? 1.5, right? Check. (300 divide 200) 1.5. okay, and if I will take here 400, then the duct will come 150. Then what will be the aspect ratio? 400 divide 150, aspect ratio is 2.6, right? So always we have to try to come near to the 1, okay, because if we will keep our duct size near to the 1, then the duct material, okay, will be less when we fabricate, right? Will be less. So which one is near to the 1? 2.6 or 1.5? Of course 1.5. So our duct size will be 300 by 200. It is clear? Okay, here 300 by 200. So I will take this one, and here we will come, see, it is supply type is supply air, and 300 into 200, right? Here we can, we'll say later. Right, clear? This main duct. Okay, now I have to connect this one, right? Branch. See, the branch, see, the 600 into 600, it is this face size of this air terminal. I already explained air terminal session, okay, and 300 into 300 is the neck size, okay. Neck size, it means that size will connect with the duct, okay. 300 by 300, here 300 by 300 will connect with the duct. Let me show you. Here, see, if the duct, this is duct, okay, so our 300 by 300 will connect here, okay. So the main duct, it means here the branch duct will go here, that width should be greater than 300 by 300, okay. How many greater? at least minimum 50 mm. It means if the neck size is 300, then the width of the branch duct should be 350. Is it clear? Okay. If the neck size is 300, then the branch duct width should be 350, minimum 50 mm greater then. Okay, because both side here the here and here should be 25 mm this side and 25 mm this side, so it will be 50 mm both side should be greater. Okay, and the similar here, if this is the main duct, okay, this is the height, right, this is the height of the duct. Okay, this is the height, right? So this is the main duct. When we will take the branch, we will take the branch from here, right? Then similar things, both side should be at least minimum 25 mm gap. Okay, it means if the main duct here, see, if the main duct height is 200, then branch duct height should be 150 mm. Okay, branch duct height should, okay, so height also, the branch duct height should be at least 50 mm less than the main duct height. Okay, and the branch duct width should be 50 mm greater than the neck size of the air terminal, so it will be easy to fabricate the duct and easy to connect the duct, right? Now see, come here, this is the 108.5 liter. So how to size, just come here. Okay, 108.5, and now we will select the head loss 108.5, and the head loss we know 0.82. we already fixed this head loss, okay, because this is the equal friction method, so this 0.82 head loss should be throughout the system. We already find this 0.82 head loss. Okay, and here the width should be how much? At least 50 mm greater, right? So here if I take 350, then the height is 100. Okay, it is fine. If I take 150, so also it is fine, right? 350 by 150, right? Okay, it is fine. 150 here, see, 350 divide 100, 3.5 aspect ratio. Okay, and 350 divide 150, how much aspect ratio? 2. So I will take this one, 2. Okay, 350 150, so come here. Okay, or create similar, come here. Okay, how much? 350 by 150, here come, you can come here, right? See, this shoe is coming automatically because I already set the routing preferences. Okay, here routing preferences you can set and it will come whatever you want, you can set. Okay, now similarly you can connect here, same thing, right? So we have to create similar, come here, you can connect like this also here, and after that you can reduce, right? What reduce? 350 and 150. Okay, you can here, the width is, the here width is 300 and after that width is how much? 350. Okay, the reducer is also like this, you can check in 3D here like this, see here. Okay, so also it is fine, right? We can size that up. See, yours is, it depend on the designer. If here I can take also 450 and 150, then it will show better. Okay, but it is also up to the mark, right? And we can connect this one. If I take connect here, see, if I will try to connect here, connect via duct, see this duct. Okay, so it is connecting, no, why? Because we have to align this one. We can move this thing, see now it is connect here, perfect with the shoe. Okay, but the air is coming from here, so this shoe piece direction should be this side, right? Now it is perfect, here air will come and come into the space, right? This is the thing. Also this one we can connect here, come to the align here and tab. Okay, now come here and connect to the duct. Okay, click this one, select and rotate. Okay, so rotate this, now it is good, see. Okay, this is extra thing, right? So we can split this one, this thing it is, and also this thing extra we can split and delete, right? And add what? Add the cap, add insulation, or see here, here, right click, you have to add the cap. Add, okay. See, I already explained this one, and this union, when I split, so it came, so I can delete and click the duct and cap ends, close. Okay, I have to close, otherwise air will be outside. Cap open ends, okay, both side I close. So this is the thing. I already explained how to fix the head loss and how to size the duct, okay, as per the standard and aspect ratio. Now come to the next point. Here, see, from the FCU to the first supply, the first branch, it is called EDL, okay, effective duct length. Okay, we cannot take branch from anywhere. Okay, this EDL I have to fix and I have to calculate. Okay, so now how to calculate as per the standard? How? From the machine to the first branch is called EDL, effective duct length, and I have to fix that one. Okay, the C, I already explained this one. Branch duct height should be less than main duct, at least 50 mm. Okay, and branch width should be greater than air terminal neck by at least 50 mm. So keep this one in mind. This is the effective duct length. Okay, see, for 100% effective duct length, if the velocity is greater than 30 meters per second, then this formula I have to use. Okay, and when velocity is less than or equal to 13 meters per second, then this formula I have to use. Okay, so our velocity, we know that 4 meters per second, right? 4 meters per second. So L is equal to L, the effective duct length is equal to under root, right? Root area, the main duct area is 300 into 200, okay, by 350. So if we calculate this one, if we calculate the 300 into 200 into 200, then it will come 60,000, right? But see, the area, duct area in mm square, and length will become in meter. The velocity will be in meter per second. So 300 into 200 will come this one, and divide 350, 60,000, right? So under root 60,000, how much? No, I did mistake, I think. 60,000 under root 244.9, it means 245 divide 350. How much length? 0.7. okay, this length will come in meter, right? 0.7 meter, so it means 700 mm, right? So from here to here, how much distance? 7. It is greater than 700, right? This is 1740, but as per the effective duct length, it should be 700 mm. Okay, this is the minimum length. This branch we cannot take less than 700 mm. Okay, so it is more than 700 mm which I take our branch, so it is good, and it is as per the standard we can take. Okay, we can also if we want, we can also adjust this one near, no issue. Okay, this one we can adjust near here, and we can adjust near. See, this is fine, this is fine, this is fine, this is fine, this is fine. Now not fine. Okay, so now you got my point. Okay, I already explained all the things about the duct sizing and the duct effective length, all these things. If you have still doubt, so you can comment below, and if you learn something, then of course comment and subscribe. Okay, Assalamu alaikum rahmatullahi barakatuh. Thank you very much.